Hello, ladies and gentlemen. I hope you're having a good day. We are getting into our sixth section of the trigonometry unit. We're going to be plugging away in here. I've made some adjustments, so there are actually only 2 more sections after this. So only 1 more week of work for you. So we're going to get into the law of sines today. There are 2 ways that you can use trigonometry without right triangles. One of them is called the law of sines. That's what we're working with today. The other one is called the law of cosines, and we'll work with that next week. So the law of sines is, just like I said, it's a way to use sine ratios without right triangles. Let me zoom this in here. All right. A way to use right triangles. Oops, not use right triangles. What am I thinking? Use trig ratios. Trig ratios without right triangles. So, this law of sines has a formula. And the formula for the law of sines relates the sides of a triangle with the angles of that triangle, even if that triangle is not a right triangle. So the formula goes like this. It says the sine of A over lowercase a equals the sine of B, capital B, over lowercase b, equals the sine of C over lowercase c. Okay, this is capital C on top, lowercase c on the bottom. And what this means is if we have a triangle, any kind of triangle, I'm going to draw one here that's not a right triangle. It looks like a right triangle. It's not a right triangle. We'll pretend it's not. And if we call the vertices A, B, and C, we're always going to call our vertices capital letters, and then we're going to call the side across from the vertex a lowercase letter. So here's vertex A. Lowercase side A is right across from here. Here's vertex B. Lowercase side B is opposite of it. Here's side C. Lowercase side C is opposite of it. So this is what we're talking about. The sine of A over side length A is equal to the sine of angle B over side length B, and so on. You don't need to use all 3 at once, and typically we don't use all 3 sine ratios at once here. We could just use the law of sines with side A and side B. Or we could use it with side B and side C, or with side A and side C. So we don't need all 3 of them in order to use this. All right, and so we're going to use the law of sines in a bunch of different ways today, a bunch of different applications for the law of sines. The first one here is to find specific measurements, okay? We want to find AC. So that tells us we want to find side length AC. I'm going to call it X just so we have something to call it. Actually, I'll call it lowercase b. That makes more sense because it's right opposite of angle B. So what we need to do is we need to set up a proportion using the law of sines because we need to know this b right here. So I'm going to say, all right, then that means that sine of angle B is 22 degrees, so sine of 22 degrees over side B, the opposite, is going to be equal to either sine of A over A or sine of C over C. Now for this one, we have angle A, but we don't have side length A, and that's going to be hard to find. We have side length C, because it's opposite of angle C, side length C, but we don't have angle C. But we do know something about triangles, so we can find angle C really easily, because we know there are 180 degrees in a triangle. So this isn't trig, this is just general. So we can say 180 minus 118 minus 22 will give us angle C in degrees. And angle C then in degrees is going to be 40. So angle C is 40 degrees. So now we have both angle C and side C. So we're going to use this part of the law of sines. We're going to say it's equal to sine of angle C, so sine of 40, over side C, which is 24. All right, so there's a proportion. You can solve this proportion in any way you want. We know how to solve proportions. So first things first, make sure your calculator is in degree mode. We need degree mode for this whole section because we're working with degrees here. So what I might do is be like, well, sine of 40 over 24, I'll say sine of 40, close my parentheses, divide that by 24, and I get 0.026 roughly. So I'm going to say sine of 22 over b is equal to 0.026. And then I can solve from here. I can multiply both sides by b and then divide both sides by 0.026. And I know now that sine of 22 divided by 0.026 is equal to b, and that's what I'm going to need to find. Now, I'm going to continue using this number, and I would suggest that you do this because these decimals are kind of finicky. Like being off by even a couple of thousandths can change your answer dramatically. So instead of typing in your calculator sine of 22 divided by 0.026, just use the answer function in your calculator. So sine of 22 divided by second, and then the negative key will give you the answer. So sine of 22 divided by the answer up here. And then that's going to give us our number. So b is equal to 13.99 roughly. So side b, which is the same as AC, is 13.99 units long. Right, pretty close to 14. So same thing here, find AB. So we need to find side AB right here, which could also be called side lowercase c. We have angle C, which is helpful because we can say the sine of 53, the sine of angle C, over side C is equal to, and then we decide, do we have sine of A and side A, or do we have sine of B and side B? And it looks like B is what's going to help us here because we have both measurements we need. So we'll say sine of 44 over 7. Right? And once again on your calculator, you can figure out the sine of 44. Close your parentheses, divided by 7, and we get the sine of 53 over c equals 0.099. And once again, same solving process as before. Essentially, we're doing the sine of 53 divided by 0.099 to get c. So we'll say sine of 53 divided by second answer on the calculator, so we can use that whole decimal, and we get 8.04. So c is equal to 8.04. And once again, side C is side AB. We can also do what's called using the law of sines to solve triangles. And when we say solve triangles, what that means is we're going to find all angle measures and we're going to find all side lengths. So when we're solving a triangle, we're solving it for everything in that triangle. What I like to do is set up a chart for myself to figure out what I have and what I still need. So I'll go here and I'll say, well, a triangle has 3 angles, angle A, angle B, and angle C. And it also has 3 sides, lowercase a, lowercase b, and lowercase c. So I'm just going to go through here, and I'm going to write down our given information. So we have measure of angle A is 70. And we know that side C is 26, and we know that side A is 25. And we need to find the rest of this information. So what we're going to do is we're going to say, well, I have angle A and side A, so that can help me to establish a baseline ratio. I can say that the sine of 70 over 25 is equal to either the sine of B over B, but we don't have either piece of information there, or the sine of C over C. That can help us to figure out what angle C is. So we'll call this sine of C over 26. Okay? So now we're going to solve the proportion. So sine of 20 over 25 divided by 25 like that. Oops, sine of 70 rather. And that gives us 0.037. And then to find sine C, I'm going to multiply both sides by 26. So I'm going to take that times 26. Let me write that out. 0.037 equals sine of C over 26. Then we're multiplying both sides by 26. And we get 0.977 equals the sine of C. Now be careful, 0.977 is not the number of degrees of angle C. It's the sine of C. So think way back to the first couple sections. We need to use inverse sine to figure out the degree measure of angle C. So we're going to say if 0.977 is equal to the sine of C, that means that we can say that the sine to the -1 power, the inverse sine of 0.977, is equal to the number of degrees in C. And again, in my calculator, that'll be second sine. And I want to use this whole decimal, so I'm going to hit second answer. That way I can use the whole thing. And I'm going to say, what's the inverse sine of that decimal? It's 77.76. So C is equal to 77.76, or 77.8 degrees. All right? So I can move over here and I can say C is 77.8 degrees. And now I still don't have any of the information for side or angle B. But I know about triangles, and I know that altogether my triangle angles add up to 180. So I can say 180 minus 70 minus 77.8 is going to be equal to B. So 180 minus 70 minus 77.8 is going to give me 32.2. So angle B is equal to 32.2 degrees. So I can put that here, 32.2. And then I need to find side B by doing one more ratio. So I can either choose side A over A or side C over C to use. I'll just use A over A. So I'll say sine of 70 over side A, which is 25, is equal to the sine of 32.2, or B, over side B, which I don't know. And again, I'll just figure out what this is. So sine of 70 divided by 25 is equal to 0.037 equals sine of 32.2 over B. And of course, when you manipulate this around, we're doing the sine of 32.2 divided by 0.037. So we'll say sine of 32.2 divided by second answer. And we've got B is equal to 14.2, roughly 14.2. So B here is going to be equal to 14.2, that side length. Right, we can do the same thing on the next example. So here I need to write down my angle A, angle B, angle C, side A, side B, side C. And what we've been given here is angle B is 45 degrees, and A is 28, B is 27. So in this case, we've got all of the information for B, so we'll use that as our baseline ratio. We'll say the sine of 45 over side B, which is 27, is going to be equal to, then we can solve A. So we can write the sine of angle A over, and then our A is 28. So there we're going to figure out our answer here. So I'll go sine of 45 divided by 27. And then obviously we have to multiply that resulting decimal by 28. So I'm going to say times 28. And we get 0.733 equals the sine of A. And of course I don't want the sine of A, I want angle A itself. So I'm going to use inverse sine to find that. I'm going to say inverse sine of 0.733 is equal to A. So we'll go on the calculator. Inverse sine of the answer, keep that whole decimal as much as possible, is 47.1. So the sine, not the sine rather, but A is equal to 47.2 if we're going to round up. So A is 47.2 degrees. We can put that over here. 47.2. And then we can use the same process to find the angle C as we did last time. We'll take 180, subtract 47.2, subtract 45. And so 180 minus 47.2 minus 45 is 87.8. So angle C is equal to 87.8 degrees. And we need to find out then what side length C is going to be. So we'll use A and A again. We'll say the sine of 47.2 over side A, which is 28, is equal to the sine of angle C, 87.8, over side C. And we'll solve that. So let's see, the sine of 47.2 divided by 28. And because of the way algebra works, we'll then need to say that sine of 87.8 divided by this number will give us C. So the sine of 87.8 divided by the answer equals, oops, that did not work. I didn't close the parentheses. So we'll try that again. Sine of 87.8 divided by, don't use answer if you make a mistake because it'll use this number. So we had 0.026204, that should be enough. And we get 38.13. So C is equal to 38.13. 38.13. And our triangle is solved. We know all the angles and we know all of the side lengths. On the back, we're going to do two other things. This first one is kind of interesting. We've never thought about this before. How many triangles can be made from each of the following combinations? So it's possible that we can take this angle, this side, and find more than one possible triangle. If you remember all the way back to the first couple weeks of this class, we used some strategies to prove that triangles were congruent. Things like side, angle, side, or side, 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 or angle, angle, side, those kinds of things. And we said that some combinations would not lead to triangles that were congruent because it was possible for some combinations to give you a configuration that could make more than one different triangle. That's what we're going to look at here. We're going to say, well, how many triangles can have the measure of angle C be 63 degrees, the measure of side B be 9, and the measure of side C be 12? All right? The reason that there might be more than one comes from the unit circle. Bet you didn't think the unit circle would pop back up again. So it comes from the unit circle because in the unit circle, the sine of an angle can be the same in different places. So the sine of 30 degrees is 1/2, but the sine of 150 degrees is also 1/2. So if an angle in a triangle has a sine of 1/2, it could be a 30-degree angle or it could be a 150-degree angle. If an angle in a triangle has a sine of the square root of 2/2, it could be a 45-degree angle. But if the sine is square root of 2/2, it could also be a 135-degree angle. So what we're trying to do here is we're going to see if it makes sense for a triangle to have a 45-degree angle, or if it makes sense for that same triangle to have a 135-degree angle in it, or if it could be either one. We're going to check. The way that we do that is we're going to use the law of sines. So if we have the measure of angle C is 63 degrees, B is 9, and C is 12. So I'm going to say, okay, so I'm going to set up the sine of C. So the sine of 63 over C, which is 12, is equal to the sine of B. We're going to look for angle B over B, which is 9. So we'll figure this out first. We're going to say, all right, sine of 63 over 12 is going to be 0.07 is equal to the sine of B over 9. So of course we'll multiply both sides by 9. And I'm continuing to use the same decimals here. So I've got 0.668 is equal to sine of B. And I'm going to here want to find the actual measurement of angle B. So I'm going to say, all right, so 0.668 is the sine of B. So I'm going to say the inverse sine of 0.668 is going to equal B. So inverse sine of 0.668 is equal to 41.91. So B equals 41.91. Now, remember, based on your unit circle, there are actually 2 places on the unit circle where the sine is 0.668. One of them is going to be over here at 41 degrees. The other one is the mirror spot, right? It's got to have the same y value. So across the circle, the same y value is going to be over here somewhere. We can find that same y value by doing 180 minus 41 degrees, and that's going to give us where we need to be on the y's. So we'll say, all right, so this is one possibility for B. The other one is if we do 180 minus 41.91. So 180 minus 41.91 is going to give us B equals 138.09. That's another possibility. B could be 41.91 or B could be 138.09. What we need to do is we need to ask ourselves, is it possible for a triangle to contain side or angle C with 63 and angle B with 41.91? And the way I'm going to check is to add them together. I'm going to say 63 plus 41.91 is equal to 104.91. That number is less than 180, right? There are 3 angles in a triangle. We don't know what the third one is, but it's less than 180, which means this angle and this angle together plus another angle will make 180 degrees. So we can make that triangle. Let's try using this other B. So we can say the 63 degree angle plus 138.09 is equal to 63 plus 138.09 is equal to 201.09. That's more than 180 degrees. So no matter what the third angle of this triangle would be, we can't have a triangle with these 2 angles. So this set of measurements can only make one triangle. So one triangle set of measurements. All right, let's look at the other one. So in the other one, we've got the measure of angle B, we've got A, and we've got B. So we'll put them together with the law of sines, and we'll say the sine of B, or the sine of 33, is equal to, over 22 rather, is equal to the sine of A over 27, and we'll solve this. So sine of 33 divided by 22, that's 0.024 equals sine of A over 27, and of course multiply both sides by 27. So times 27, we get 0.668 is equal to sine of A. And then we want to find angle A, so we're going to say the inverse sine of 0.668 is equal to A. So inverse sine of 0.668. I'm going to use, again, the answer function on my calculator, and that's going to give me 41.94. So A is equal to 41.94. That's a possibility. There's another possibility for A, right? Because if the sine of A is equal to 6.668, the same y value on the other side is going to also be the sine of A. So we can say, well, what if we do 180 minus 41.94? 180 minus, this answer is going to give us 138.05. So A could also be 138.05. Let's test each A value to see if it would work. So if this A of 41.94 was to combine with this B of 33, would there be space left for 180? Let's see. Together they make less than 180. So that works, right? These 2 angles plus a third angle somewhere are going to make less than 180, and they're going to be the angles that we need. Let's try 138.05. So if we've got the measure of angle B, so 33 plus 138.05, try that out. 33 plus 138.05, that's also less than 180. So the third angle in this triangle would be small because this adds to 171. It would be like 9 degrees, but it would still be there, and this would still be a good triangle that will work. So this makes 2 triangles. There are 2 possible triangles we can make out of this configuration of lines and angles. All right, last one here. What is the area of a triangle using the sine rule? Okay, what we're going to do here is we are going to use the altitude to help us out. So for this one, triangle EDF, what I'm going to do is I'm going to draw the altitude right here. And if you notice, in this triangle, my 99 degrees is part of an isosceles triangle. I have 11 and 11, which means that when I make an altitude here, it's also going to cut this in half. So instead of 99 degrees, it's going to be 45.5 degrees and 45.5 degrees over here. And what we need to do is we need to find the things we need to find the area of a triangle. So we need the base and we need the height, because base times height divided by 2 is the area. So we're going to need to find EF, and we're going to need to find this line here, the height of the triangle. We're going to use sine to do that, okay? One thing to note is if this angle is 45.5 and this angle is 90, we can easily figure out what angle E is, because we can say that 180 minus 90 minus 45.5 is going to give us 44.5. So angle E is 44.5. And we're going to use that angle to help us. Because if we're using angle E, then the sine of angle E is going to be the opposite over the hypotenuse. Remember in SOHCAHTOA, we know that the sine of 44.5 is equal to the opposite. I'm going to put an x there because we don't know that one. It's equal to x over the hypotenuse, which we know. The hypotenuse of this little right triangle is 11. So we're breaking a triangle that's not a right triangle into right triangles in order to use right triangle trigonometry to solve. So we've got the sine of 44.5 equals x over 11. And I can multiply both sides by 11. And I can say 11 sine of 44.5 is equal to x. So let's find out what that is. 11 sine of 44.5 going to be 7.71 equals x. So this value